Okay, here we are again with a very incomplete review of Unit C, Newton's Laws of Motion, Parts 2. Okay, so we have a bowling ball that's hanging from the ceiling, and there's two wires here, and they're both at the same angle with the vertical. And would you know how to find T1 in the Y direction? So the tension here in the Y direction, could you try and find that, please? I'll see you in a little bit. Go ahead and pause. Okay, we're back. And T1, did you really pause? You better have. All right, so this next one, T1 in the Y direction is going to be, do you see how if we break this up, T1 is going to be some in this way and some in that way, and here's T1 in the Y direction. And this would be the same. It's going to have the same tension. And so we have two forces that are holding up 3 kilograms. So if this is 30 newtons, then I'm thinking that the tension in this rope right here is 30 newtons upward, which means it's pulling down on this 30 newtons. Now the downward force of 30 newtons here is being balanced by both of these. So both of these are 30 newtons. So T1 in the Y direction is 15 newtons. That's because if this is 15 newtons and this is 15 newtons, then that will hold up the 30 Newton bowling ball. Onward. Okay, here we are. Now the bowling ball excuse me, is 2 kilograms, and this is a horizontal line. This is 45 degrees. And could you find out what T1, T2, and T3 are? Go ahead and try and find those out. I'll see you in a little bit. Go ahead and pause. Okay, we're back. Okay, T3 is going to be 20 newtons because if the earth pulls down with 20 newtons, then T3 better be pulling up with 20 newtons. So T3 is 20 newtons. Okay, from that, we can reason then that T2 is going to, we can break this T2 into, it's going to be we can break it into 2 parts. Now, this is the only force in the Y direction because T1 is all in the X. So if that's the only force in the Y direction besides T3, then this is going to have to be 20 newtons. If that's 20 newtons, then this has to be, if that's 45 degrees, this has to be the square root of 2 times 20 newtons. So T2 is the square root of 2 times 20 newtons. Or you could use some trig to get that. So that's what T2 is. Okay, T1, if this is 20 newtons and that's a 45 degree angle, then this right here has to be 20 newtons. T2 in the X direction has to be 20 newtons. So that's force is in the X direction, so is this one. So they have to balance out because otherwise that knot right there is going to go one way or the other. So T1 is 20 newtons. Excuse me. Moving right along. Here's a bowling ball on a string. You pull up on the string with 18 newtons. What will the acceleration of this bowling ball be? Go ahead and pause. Okay, well, the acceleration of this bowling ball is going to be, just do a little Newton's laws. There's 30 newtons down. Well, I should have made that vector bigger because that's bigger than 18. It's going to accelerate bigger. Let me go ahead and do that. Okay, so that means that the acceleration, since this one's winning, I'm going to say that's 30 newtons minus 18 newtons all over 3 kilograms. So the acceleration, that turns out to be 12 newtons divided by 3 kilograms is going to be 4 meters per second squared downward. Here's a bowling ball that's swinging in a circle. Can you find out what V is if we know the radius of the circle it's swinging in is 2 meters, that the tension is 36 newtons? what will be the speed of this? I think we need to give you the mass of this. Let me tell you the mass is 2 kilograms. So that's a 2 kilogram ball. So what will be the speed of this when it comes through its lowest point if the tension is 36 newtons at that point? Go ahead and pause. Okay, so I'm just going to apply Newton's second law. So there's a force down of 20 newtons. And there's a force up of 36 newtons. So A equals F net over M. So V squared over R equals, I'm going to say 36 newtons minus 20 newtons, all over the mass, 2 kilograms. So that's going to be, let's see, this is going to give me 16 over 2, that's 8. And then if I multiply by R is 2 meters, so that's going to be, V is 16 meters squared over seconds squared, and then we'll square root it, since R is 2 meters. And so I'm getting that the speed is 4 meters per second. That's what the speed is. Did you get that? I hope so. Next one. Okay, here's a crate that's going over a hill. As it goes over the hill, what's the minimum speed it can go and not leave the hill? You know, if it goes too fast, it's going to go in projectile motion. So what's the minimum speed it can leave and not go over, that it can go over the hill and actually stay in contact with it, just barely stay in contact with the hill? Okay, go ahead and pause and try and figure it out. It's 4 kilograms and 10 meters, the radius of the hill. Go ahead and try and figure it out. Okay, so if we draw a force diagram, we have mg down, and then the normal force would be up, but the normal force at the minimum speed, the normal force goes to 0 because it's just barely leaving. So this is going to go to 0. So A equals F net over M. That's V squared over R because it's going in a circle, is equal to F net. It's just mg all over M. So A equals F net over M. Get rid of some the m's. And the speed is equal to the square root of Rg. That would be the square root of, what's R? 10 meters. And G is 10 meters per second squared. So it looks like the speed, the fastest it can go and still stay on, is 10 meters per second. If it goes 11 meters per second, it's going to go off. It's going to actually leave the road. See if we can sneak one more in. Okay, so here's a crate that's going 4 meters per second. It's 2 kilograms. That's the mass of the crate. It's going around a circle that's 4 meters. This time they want to know what the normal force is. What will be the normal force when it goes into this dip? Okay, go ahead and pause and try and figure it out. Okay, here we are. So draw a force diagram, and the force diagram is going to be mg down, and the normal force has to be bigger because it's accelerating upward because it's going in a circle. So A equals F net over M. So A let's just change that to V squared over R is equal to F net, which is going to be Fn minus mg, all over M, and M is 2 kilograms. All right, so V squared is 16 meters per second squared. That's going to be 16. R is 4, so this is going to give me 4 times 2 is 8. So 8 newtons equals Fn plus, and this is going to be minus 20 newtons. So Fn looks like it's 28 newtons.